Hello everyone, welcome to my presentation. First of all, let me thank you all for coming to it today. Let me start by saying a few words about my own background. This is Nızar, I'm a student in Gaziantep University. As you can see on the screen, our topic today is mechanical properties of normal and steel fiber conformist, lightweight, geopolymer concrete. My first point for research aim. This is the research aim to produce slag-based geopolymer concrete using lightweight artificial aggregate which has been manufactured from slag in order to reduce the adverse environmental effects. The properties of amount of lightweight aggregates used to have a significant impact on the properties of the concrete. Therefore, in this study, experimental research was conducted to investigate the impacts of replacing coarse river aggregate with artificial lightweight aggregate with steel and without steel fibers. There are three objectives of this research as follows: schematic background of the elements utilized to produce fiber-reinforced lightweight geopolymer concrete. The second, assess the geopolymer concrete's properties after replacing coarse river aggregates, lightweight aggregates. The third, analyze the effects of the addition of steel fibers on the characteristics of lightweight geopolymer concrete. As you can see in this slide, the producing of aggregates in this work, the coarse aggregate had been prepared using slag and cement by cold bonding process. The lightweight aggregates contains our type for 90% slag, 10 plus 10% cement. The aggregate curing. After producing aggregate, the period of the curing had been taken 28 days to be ready for using in the mixes. The preparation of the aggregates has been put into the water for 24 hours. After 24 hours, the aggregates has been dried under the sun for 1 hour before using in the mortar, in the concrete. The mixing process, in the first and second steps, sand was added and mixed with fly ash. In the third and fourth steps, as you can see, lightweight aggregates were added and mixed wool. In the fifth and sixth steps, steel fibers was added to the mixture by distributing it to wool. In the last two steps, the sodium silicate and steel fiber with the rest of steel fiber were added in the mixture. You can see this video, and you can see this video for adding the steel fiber, and this slide for slump test. As you know, the slide the slump test for measures the consistency and workability of the mortar. You can see in this slide the models photos before casting, and this is models after the casting, and this is the samples after the casting, and this is samples before testing, and this is samples after testing for both types of steel fibers. And this is test results. As you can see, we have six mixes of my research, and in this slide you can see the comparative strengths for 7 days and for 28 days, after 7 days and after 28 days. And this slide for the splitting tensile strengths after 7 days and after 28 days. And this is a conclusion. We have 5 points for conclusion. The performance of lightweight aggregate geopolymer concrete is close to normal ordinary Portland cement concrete in terms of workability and mechanical properties. Moreover, these properties can be approved for construction application on sites. The second, the presence of the steel fiber in lightweight geopolymer concrete mixture with 0.5% and 1% significantly improved mechanical properties. However, the slight degrees of 1% steel fiber mixture workability The third, the high bond between artificial aggregate and steel fiber with a geopolymer mixture was observed in all mixtures. And for the compressive strength ranged between 29.96 and 58.17 megapascal at 7 and 28 days respectively. And for sliding tensile strength ranged between 2.02 and 5.67 megapascal at 7 and 28 days respectively. Thank you for listening.